Thank you to OC3 for having me as a speaker today. I'm really excited to talk to you all about this topic. I suspect that maybe this audience doesn't need such an in-depth introduction to Intel SGX. It was first announced in 2014, so can you believe it's been 10 years now that this has been in the public domain. SGX allows user mode applications to set up a protected region in memory of code and data. And SGX provides architectural access controls and hardware primitives that provide confidentiality and integrity and local and remote attestation for the code and data that runs inside of an SGX enclave. And because it's process-based, it has a smaller TCB than some other commodity TEEs, for example, those that are built on virtualization. You can have a very small code base and put one of these into an SGX enclave. Now, since SGX was announced back in 2014, Intel's been continuously supporting it. We've got some recent milestones as SGX was first launched for data center products back in 2018. Those are the Xeon E processors. And then what we heard since that time is, wow, there's so many great applications for SGX and confidential computing in the cloud environment and on servers, but we need more memory. We need more EPC. At that time, I think the maximum that was permitted for SGX was about 512 megabytes. And so in 2021, when Intel SGX launched with the Ice Lake generation of server processors, we increased that threshold by a factor of 1,500 to 1 terabyte. So now you can have 1 terabyte of enclaves on one of these server processors. And that allows for a lot more capabilities, a lot more use cases. Ice Lake also introduced a lot more new hardware accelerators. We began to introduce more accelerators like to boost deep learning, for example, to do more advanced vector and matrix math. And SGX also protects those workloads. Those accelerators are covered by SGX's protections. And I believe it was also in that same year, 2021, that the SGX driver was finally merged into the Linux kernel. I think it was Linux version 5.11 that got that, and that allowed even broader adoption of Intel SGX. And then that brings me to 2023, when we announced this new extension to Intel SGX called Asynchronous Enclave Exit Notify, or AEX-Notify. And this is first available out of the box on 5th gen Xeon Scalable processors, codenamed Emerald Rapids. And what's really interesting and exciting about this feature is it's also back portable to older server products via a microcode update. And I'll talk more about that later. Before I describe how AEX-Notify works and what it does, I need to do a quick refresher on how application threads enter and exit SGX enclaves. So we can think of units of enclave execution as like executing a function. It's sort of like a DLL in your address space. And so you call functions in this DLL, the thread goes into the enclave, finishes executing the function, and it exits. So SGX provides an instruction called EENTER that a thread invokes to enter an enclave. And during the course of ordinary benign enclave execution, sometimes exceptions occur. That could be like a page fault or a divide by zero exception or many other kinds of exceptions, or an interrupt, like from the advanced programmable interrupt controller. And that triggers what we call an asynchronous enclave exit, or AEX. And then if the operating system needs to handle an exception, it'll do that. Or if the next time it schedules this thread to run, the user mode application will invoke a different instruction, eResume, to resume enclave execution at the point where that interrupt or exception occurred. And the enclave just picks up where it left off and keeps running. Then when it finishes executing that function, the thread will invoke a different SGX instruction, EEXIT, and it'll go back to non-enclave ring 3 behavior. Now, I did say Under ordinary circumstances, it behaves like this. But what about extraordinary circumstances, and the kind that are very interesting in the confidential computing context, where we assume as part of our threat model that the operating system or VMM, the privileged software on the system, might actually be untrustworthy or malicious? So this has been a topic of intense academic interest, is actually using exceptions or interrupts, especially page faults, to induce frequent asynchronous enclave exits. And why might a malicious adversary be interested in doing this? Well, if you're trying to amplify or use side channel data inference, like examining the sequence of pages that an enclave accesses, or examining the sequence of cache lines that the enclave thread touches to try to draw inference about what the enclave is doing, it might be easier to do that if you can interrupt or trigger exceptions very, very frequently. So you can kind of have a finer grained side channel analysis if you're able to force this behavior. And there are some tools that exist in the open source domain that advertise or claim to be able to maliciously single step or zero step an SGX enclave. So by single stepping, we mean executing one instruction inside the enclave at a time and then interrupting it. So the enclave exits right away, and then after each instruction, the malicious OS can maybe take some side channel measurements. And then another category is behavior called zero stepping, where the enclave actually doesn't make any forward progress. It repeatedly hits like the same fault and exits, and even though the enclave doesn't make architectural forward progress, it might execute some instructions transiently. They might execute in the microarchitecture, but not commit. And that can also manifest in some side channel leakage that the adversary might be able to observe. So how can AEX-Notify help this situation? Let's look at the same situation, but let's see how an enclave would react when it is enabled AEX-Notify. So it still gets the asynchronous enclave exit when it encounters an interrupt or exception. But then when it re-enters with eResume, AEX-Notify actually causes a different behavior. The enclave will not resume at exactly the point where it left off. Now the enclave becomes enlightened to the fact that an exit had occurred, and it can react by deploying some software code, like a software mitigation. And so what I'm about to describe is actually the default mitigation that comes with the newest versions of the Intel SGX SDK. And what it does is it uses some heuristics to determine the enclave's current working set. What code pages is it using? What part of the stack? What heap pages? And it preemptively accesses and prefetches the data on those pages. It doesn't do anything with the data. It doesn't operate on the data. So it's not like it's going to expose anything sensitive. And this is public code. The code itself is not secret. It's not doing anything with secrets. It's just estimating the working set and preemptively triggering those exceptions so that they don't happen when it eventually returns and resumes the enclave application. So it acts kind of like a sentinel. It looks ahead and triggers the potentially bad things that could happen, but in a benign way where they're not going to reveal any sensitive information to an adversary. And then if it keeps encountering those, it's just going to keep exiting and resuming and trying again. And it will only allow forward progress of the enclave application, the part that's really security critical that the user cares about. It will only resume that when it doesn't encounter an interrupt or exception. So AEX-Notify, as I said at the beginning, available today on Emerald Rapids processors out of the box. These other processors listed here get AEX-Notify by a microcode update. Our Sapphire Rapids or 4th gen products get those by a post-launch release update. And then all older processors get it by an Intel platform update or IPU. AEX-Notify driver support was merged into Linux kernel 6.2, and Intel SGX SDK support has now been around since version 2.20, and that was released about a year ago, I believe. So you can get Ubuntu today, you can get the SGX SDK, and you can have AEX-Notify. And then support is coming to the Grameen framework for running unmodified binaries in SGX. Support for AEX-Notify is coming soon. So I'm going to flash a quick disclaimer, and then I'm going to go back to my summary slide, and now I'm going to take some Q&A. And I should also mention that I'm going to be hosting a breakout room at, I believe it's 12:30 p.m. Pacific. I don't know what that translates to in Central European time, but it's about an hour and 15 minutes from right now. So if you're interested in this topic, you want to have a deep dive on how all of this works, I know this is a pretty high level, I'd invite anyone to come and attend that. Thank you very much.